IIT Madras, IITM Pravartak Technologies Foundation, and Ziroh Labs. As the world races forward in AI development, one critical roadblock has been the shortage of GPUs, limiting both speed and scale. But this launch aims to change that. Together, we are introducing a solution that has the potential to accelerate AI research and deployment. We truly appreciate your presence here today and look forward to unveiling this groundbreaking innovation with all of you. As a mark of respect, I now request everyone to raise for the Tamil Thai Varthu.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராரும் வதனமென திகழ்வரத கண்டமிதில் தெக்கணமும் மதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரிதனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே 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 வந்தே மாதரம். Vande Mataram.
Thank you all. Please be seated. Now I kindly request Professor S. Sadagopan, Mr. Ajay Goyal, Professor V. Kamakoti, Mr. Rishikesh, and Professor Madhusudanan to take their seats on the stage. To commence the event gracefully, I invite our esteemed guests to the stage for the lamp lighting ceremony, formally inaugurating today's proceedings. Professor V. Kamakoti, Professor S. Sadagopan, Mr. Ajay Goyal, Mr. Rishikesh, and Professor Madhusudanan. I request Ms. Agneta D'Souza of Ziroh Labs to be on stage to felicitate Professor V. Kamakoti, Director of IIT Madras. It is night time for the most awaited moment, the product launch. I invite Professor V. Kamakoti, Director of IIT Madras, to do the honors and speak about this path-breaking innovation.
It is on Google Chrome. I have a caller mic.
So friends, a very, very hearty welcome to IIT Madras campus. Today marks a very important day. As IIT Madras for All, we are very proud to present AI for All. This is a product that we have conceived and designed by Ziroh Labs and fine-tuned and validated by IIT Madras and IITM Pravartak Foundation, a Section 8 not-for-profit organization hosted by IIT Madras. Friends, what we had seen in the past, when digital technologies started taking the prime role in shaping our economy, one of the major challenges that many large countries, particularly India, faced was what we call as the digital divide. Predominantly between cities where we had internet access, we had access to digital resources, versus the rural India where we could not have digital access. Of course, we are bridging that at a rapid pace. Today we have the BharatNet and other sources, and also the telecommunication network is becoming much and much more robust, that we are trying to bridge the digital divide. But what we are now seeing is what we call possibly as an AI divide, where when we look at one of the major cost for AI is the GPU, the extreme amount of power that it consumes, and also the availability of such a large infrastructure, essentially raising the fear that only a few high-end resources, some few high-end companies may have this access to this large infrastructure where they can perform AI, leaving out the others who may not have access to such large resources. And this is what could be a possible AI divide. And we need to bridge that AI divide. We must act now to ensure that AI become as inclusive as possible, because AI now is becoming part and parcel of our life. So the solution provided by Ziroh Labs is a major step forward in this direction. And what we will be presenting today through demos, and we have excellent speakers who have joined online, both from India and abroad. We have Professor Sadagopan, who is the Pitamaha for all of us. He's our guru, my students' guru, and students' guru. These are people who were the initial building blocks for our India's digital revolution, and we will hear from them also, and the product will be demoed today. So what is this product all about? We are giving an affordable, scalable inference platform, which we believe is extremely important to bridge the AI divide. So the goal is AI should empower everyone, not just a few. And with this motto, it also aligns very much with IITM for all. We are now very happy to say AI for all. Now I want to basically touch upon people who may not have a good introduction to AI. I want to touch upon something. What is this GPU? I thought I'll take this morning part to give a small lecture. I'm not going to bore you about 10 minutes, but I'll finish it in 10 minutes. First and foremost, friends, let us understand what is data parallelism. Right? Suppose I want to multiply 100 numbers. If one person alone does it, he has to take one by one and multiply it. This is what in computing, we call it as sequential computing. But suppose we have 10 people who are all capable of doing multiplication. Then we can give 10 numbers each to each of them, and they can do it parallelly. Right? So that's the most important thing. So at the end of just 9 multiplications, you will have 10 partial products, which again could be parallelized. So what would take 99 multiplications to multiply 100 numbers can be finished off in 10 to 15 multiplications. And what have we done here? We are telling each of these persons multiply. Only one instruction we have given, but they are all working on multiple sets of data. So there are 100 data, so first 10 is taking, second 10 the second person is taking, and so on. So this parallel activity, I hope you can sense the parallelism here, is because of one instruction say multiply, but multiple data. And that is what we call it as single instruction, multiple data parallelism. Right? Now, why are we talking about this? The entire AI domain largely benefits by this single instruction, multiple data. There are two phases when we want to make an AI tool. One is what we call as training, which is basically you are trying to educate the AI tool about about what you wanted to learn. And then there is something called inferencing, where you start asking questions and you get answers from them. So there are two parts in this. One is training and another is inferencing. For the training part, there are a lot of these type of single instruction, multiple data computation that is necessary. And the GPUs, the graphic processing units, which were earlier intended for graphics, right? Because, in 1995, the first the first animation movie was done using a graphics processor from Silicon Graphics, right? And the main computation that happens on the graphics is a single instruction, multiple data. Like paint. What to paint would be different data on the screen. So these graphics processing units, which are as old as 1995 and they have gradually been growing up, these graphics processing unit became very good candidates for doing AI work, specifically the training part, because there is a necessity for this single instruction, multiple data. And that is why GPUs became extremely important in the AI scenario. Now, so there are two aspects, as I told you. Training. How do you do training? One thing is, if you teach, it's like teaching a kid, and the kid exactly does what you have trained it for, right? So if you teach only good things, the kid will not know what is everything. It will see as good, and in this world, it's not going to be good for the kid, right? And if you teach everything bad, it will see only bad things. So we need to have, proper teaching of what is good and what is bad. In Tamil we say, நல்லது கெட்டது ரெண்டும் சொல்லி கொடுக்கணும், right? So we teach what is good, what is bad. And that's where there is the notion of bias, there is notion of temperature, and so many things that come up, right? The training part today needs GPUs. But training is one part of the affair. But then there is an inferencing part. All of you do. How many people are not using ChatGPT? Okay? Very few, right? So, when you ask a question to ChatGPT and it answers, it is basically the inferencing part. And what we say today, for the inferencing, we do not need GPUs. We can do it with normal CPUs. And this is the product that Ziroh Lab is launching today. Am I clear? Any doubts in this? Any doubts? No doubts? Okay, good. So, இதான் இப்போ தான் சொல்லியிருந்தேன், அந்த ராமாயணம் தான் சொல்லிட்டு இருக்கேன். Okay, what is the difference? GPU is just some lot of small units doing the same instruction on multiple data. It cannot execute an operating system and all. Windowsலாம் அதில் ஓட்ட முடியாது. On a CPU, which you are using, a mobile phone is a CPU. You can use all apps. You are using wonderful apps, all these things. So that's the difference between a CPU and a GPU. CPU has been there for centuries, right? Meaning at least half a century now. We had seen the first CPU somewhere in 1960s, end of 60s. Even IIT Madras had a IBM computer, right? GPUs are the new avatars which are specifically for the AI workloads. Now, do we really need GPUs for inference? And this is the question. So I am always reminded of this particular statement which one of my teachers used to regularly tell this: you should not shoot a mosquito with a revolver. You will waste the bullet and the mosquito will still be quiet, it will be still alive. Okay? So that's the most important thing. So do we actually need a GPU for inferencing? Our analysis today, last 3 months, Rishi is here and his team is here. I think they were worked like, around 20. So one person wanted to, advertise his house for rent. So he said, day and night, 26 hours, water will come, sir. Okay, so that's the way he used to emphasize. I think they have worked day and night, 26 hours, staying in our guest house. And they have brought this. What we are today conclusively telling you is that it is not always necessary for a GPU infrastructure for inferencing, we can do it with CPUs, and that is the real important message that comes out of this particular launch. Friends, we are looking at an scalable, cost-efficient, and energy-conscious, right, deployment that we are trying to do today. And what is the motivation for this, right? See, in all our literature, there are some 64 arts, right? 64 kala. Nobody can be master of all these 64 arts. One arts. What the large language model today says, I will answer any question. Why we need it? Right? Nature has told that it is not possible. So all these large, big efforts, in my opinion, take it from me, today it will be a failure. The reason is somewhere it will hit the power barrier. You are consuming so much tons. If this way, that way data is exploding, you start training these large models that they will know anything and everything under the universe. I think we have to, at least in the next few years, we have to build a nuclear plant, then we have to go to sun for more energy. I don't think we are going to scale that. And that is the most important message we are trying to give here. Why should you be knowing everything under the universe? When I am working in, say, legal domain, I will have something specific for legal domain and a little allied areas. When I want to work for, agriculture, I will have something for agriculture. When I am working for fintech, I will have enough for fintech. Why should I do for all? And that is the real inspiration that we are getting out in this particular stuff. So when we look at some of these large models, they say 18,000 crore parameters. What's a parameter? Parameter can be lots, like it can be weights, it can be biases, it can be, top parameters, it can be the randomization. So many things are there in a model. So amount of knowledge, amount of varieties a large language model has is basically mapped onto the number of parameters that are necessary. And today, why should I work at 18,000 crore parameters? What will I do with it? And then after all these things, I was using a large language model. I was sitting on a stage with another friend of mine, and just some AI thing came in that meeting. And he said, why don't you ask about me? And you'll get a very interesting answer. So I just asked that large language model about this person X. He said he expired in 1991. Okay. Right? So what? It's not wrong. It is the amount of information can get correct. So when the information is exploding, amount of digital content is growing, the velocity of this thing is growing, I don't think that any engine can keep track of so much, and how much of power is necessary, how much of infrastructure is necessary. It's not going to be sustainable at all. It will violate every sustainable development goal which any nation has put, right? And so I want to specialize in a discipline, right? Oru kalvi uirai kakkum. Tamil. Sanskrit eka vidya surakshita. One. I should specialize in one. I can't specialize on 64. This is nature, what it has taught us. So this is a nature-inspired effort. Now what we are saying, there is a startup. They are working in fintech area. They have their own DNA. You go to a bank, you go to State Bank, you go to Canara Bank. Both are PSUs. But the profile of customers in State Bank is different from the profile of customers in Canara Bank. Right? If I want a customer relation management AI engine, a language model, how should I go and talk to the customer? If I want to actually even make an engine which will talk to the customer, a chatbot, right? The way I train would be based on the data, based on the reactions, based on the way the calls had been handled, the type of customers, they're different, right? So every organization, why I just gave the bank example, because every organization has its own DNA. So today, what this will offer is, any young startup who cannot afford those great GPUs, who cannot have this big infrastructure, who cannot even pay the electricity bill even if they get the infrastructure, they want to imbibe AI. That is the AI divide. If they cannot imbibe AI into their profession, into their organization, they are to lose, because today their competitors can, push the envelope much faster than them. So what this particular effort does it, that we go to this startup, say, what is it that you have? We basically train them. We basically train that model. For training, we will use a GPU environment. But then, we can now port that trained model onto a simple CPU environment, which can basically start answering. The users there can keep using it, and occasionally you keep retraining it with more and bringing it back. And so so every small organization can have this. And suppose I have 50 crore parameters. 50 crore parameters, which is what? 500 million parameters. Today, what we have seen is that with a server that I can go and buy in Ritchie Street, 1.25 lakhs, I can run the inferencing part. If I want to go up to 700 crore parameters, right, I have to spend around 12 lakhs. Max. 700 crore, which is 70 million parameters, right? 7,000 million parameters. 70 billion parameters, right? So this is the scalability, and as and when my parameters grow, I can gradually scale it. And these are all the most important contributions today. And friends, this is extremely deep tech. To understand this, of course, it was mind-boggling even for me to understand it as a concept. We have to know the instruction set architecture. We have to know the microarchitecture of the server. We need to know what the cache is. We need to know the operating system, the threading, the scheduling of the operating system, and then we have to work with good compilation. All these things, and a very effective database, right? We have used open source database here. The Postgres has been used here. So friends, this is very, very deep tech, very, very involved, and that's the real big contribution here. Now, what we will be doing today is that we are now we will be demonstrating, of course, Pitamaha Sadagobanji, he will make his views on this. We have participants from abroad who are very, very established people. They will also be making their comments about this for the benefit of all. I have made a very, very layman pitch. The more technical pitch will come from all of them. And then we will show some demos, very interesting demos, and then we'll take forward. So I just complete here. Can you just give me, with my mobile? I am going to complete here with a small statement. Very coincidentally, I think we are also, just to tell that we are with the world in this whole affair. This is a report on April 3, 2025, Technology and Innovation Report 2025, released in the United Nations Conference in Trade and Promotion. I just want to spend 2 minutes in reading out some salient part of this report. Artificial intelligence is on course to become a $4.8 trillion global market by 2033, roughly the size of Germany's economy. But unless urgent action is taken, its benefit may remain in the hands of a privileged few, a new UN report warns. So we need to invest in reskilling, upskilling, and workforce adaptation to the AI platform. And 3 important points are necessary for this. One is infrastructure, another is data, and the third one is skills. Data, India has it. If at all some country has it, it is India, right? I'll give you an example. One of my colleagues went to Germany, and there was a small problem for his kid in eyes. So he went to a doctor there, and there's some for 3,000 euros it will take. Then he asked, how many such surgery you have done? He said, we have done 7 surgeries. Next week he came back to here, he went to our Shankar Netralaya. When there they said some 30,000 rupees. How many surgeries? Some 8,000, 9,000. This is scale of India, right? This is scale of India. So we have a lot of data. Skills. Of course, I'm talking in IIT Madras. I'm a director. I should, campaign for myself. Skills. Friends, we have 37,000 data scientists who are going on our online program just at IIT Madras, right? And I'm also very happy to announce this year we have introduced a GATE paper, Graduate Aptitude Test in Engineering paper in data science and AI. The rank number 1, rank number 7 and rank number 10 are our BS students. Okay? And the rank number 1 is an MBBS doctor from AIMS who has cleared it and is going to join data science MTech at IIT Madras. So these are all some very interesting statistics. So skills-wise, we are top. We will continue to be the top and we will catch that position. India, Viksit Bharat 2047, as our Honorable Prime Minister wants, will be a technology superpower, and the main contribution for that would be the human capital, and we will get there. The last one is infrastructure. Are we in a position to provide that infrastructure? Infrastructure is not about the GPUs and other things. It's also about electricity. It's also about sustainability and all. And today's product is going to announce this. So I'm sure this will enable people to be at the center of a revolution. Friends, this is not just for us. This is going to be a global product. Whoever wants to take, we are going to give. We are India. We made 2 vaccines. We not only put 275 crores of vaccination here, but we also donated to nation. That is India. So we will go. This is for Vasudhaiva Kudumbakam. We are going to give for the entire earth. Friends, this is AI for all from your IITM for all. Jai Hind. Thank you very much.
Thank you so much, sir, for launching the product and for your insightful words. We are privileged to hear from Professor S. Sadagopan, former director, IIT Bangalore, one of the pioneers in IT education in India. I now invite him to share his thoughts on India innovates again in artificial intelligence.
Good morning. Good morning. Yeah. I feel really privileged to be here today with you all. It's interesting that this is a historic moment. We are making history. Let me repeat, today we are making history. And I am even more privileged that we are doing it from a very special institution, a marquee institution, IIT Madras. Hats off to IIT Madras, hats off to the director IIT Madras, and hats off to Professor Kamakoti. I am separately mentioning Director IIT Madras and Professor Kamakoti because Professor Kamakoti is contributing in both the capacities, both as a director of the institute as well as in his individual capacity. You already have seen what he covered, and you will get to see as the day unfolds. Okay? So it was Professor C.K. Prahlad, the well-known management guru of University of Michigan, who in the year 2000 showcased to the world a series of frugal innovations from India. Bombay Dabbawala in the west, Jaipur Foot in the north, and right in the south, the Arvind Eye Hospital, and a whole bunch of them. And each and every one of those frugal innovations, India demonstrated world-class solutions at very affordable costs, bringing the affordability to the center stage. And what we are doing today with the launch of Compact AI, India is innovating again. India is innovating again, not in any field, but in a very special field, in what is called the cutting edge, the bleeding edge, the deep tech AI. From today, AI development and AI deployment. Let me repeat, AI development and AI deployment will be democratized in line with the India's AI mission, AI for all. You know, tools from OpenAI, Google, Microsoft, AWS are critically depending on GPUs, as Professor Kamakoti mentioned. With limited availability and affordability of GPUs, on the top of it, sanctions from US, Indian researchers and professionals were at a disadvantage until today. India is also will develop a GPU, but it will take some time. With the launch today by the Ziroh labs of Compact AI, AI solutions can be developed at a fraction of a cost using CPUs that are available in plenty without the forced need of GPU. I'm not saying we will not use GPUs. GPUs will be used, but we should not be forced to use GPUs. Okay? AI models today have the excessive use of electrical power using GPU, a point which Professor Kamakoti mentioned. And I think talking at the IIT Madras platform, we should kind of realize that the Indian wisdom has been talking of dharma. Okay, you all know dharma is at the root of civilizational living. That there's a Sanskrit expression which says, dharma dharayati prajaha. Dharma is the one which sustains the civilization. And so it is the sustainability at the core. When you actually have solutions that does not make too much dependence on electrical power, you are also providing sustainable solution. So what we have today through Compact AI is affordable, available, sustainable. Affordable, available, sustainable. AI tools and takes on sustainability. I think thanks to Compact AI, India is kind of getting its chance to innovate again. I feel particularly happy and proud that I have been kind of watching at close quarters Ziroh Labs and Rishikesh, the creators of Compact AI, from day -1. Okay? It's a great privilege to be associated with them. A great day ahead, and enjoy the rest of the day. Take a look at the demos. As they say, some of you should fall off your seats. Thank you.
டவுன்லோட் பண்ணிட்டீங்களா? இல்லை எங்கே டவுன்லோட் பண்ண ஒரே நிமிஷம் ஒன்றே மெயிலில் எங்கே இருக்கு? வாட்ஸ்அப்பில் இருக்குது, ஆஃபீஸ் மொபைல் வாட்ஸ்அப்பில் இருக்குது. இருக்குது சார், எடுக்கிறேன் ஆஃபீஸ் மொபைல். டிஸ்பிளேல வேற இருக்குன்னு நினைக்கிறேன் சார்.
அது பிரச்சனை இல்லை. இப்போ வரும்.
ப்ளே பண்ணாலே வந்துருமா? சரி, அப்போ இன்ட்ரடக்ஷன் மட்டும் கொடுங்க. பேசிட்டு ப்ளே பண்ணுங்க. இல்லை நான் பேசுகிறேன்.
ப்ளே பண்ணுங்க.
Launched Sun and Java. There was a new.
ப்ளே பண்ணுங்க.
We are pleased to welcome Mr. Scott McNeely, founder of Sun Microsystems. Sun Microsystems was one of the most iconic companies in the world. They invited multiple products such as hardware processors and designed operating systems and programming languages like Java. The innovations introduced by Sun Microsystems became extremely popular. For instance, Java remains one of the most widely used programming languages globally. Mr. Scott McNeely successfully led the company for over 20 years as chairman and CEO.
3304.
And we have a video recording message from him to share his inspiring thoughts.
Hello, everybody. A long time ago, when we launched Sun and Java,
ये पेड़ के पास से राइट ले सकते हो ऑटो के आगे से.
forth to the market, HTML was primarily static. However,
Java.
the way programmers across the globe embraced Java, and it was easier to write code than ever before. It was genuinely object-oriented. And most importantly, it ran everywhere, right? Once, run anywhere. There was no need to worry about processor architectures, memory architectures, and so on. And as you can see, Java-enabled accessibility across the globe is the result of what we see today, the World Wide Web that is animated and
Dr. Duffy. Insightful thoughts. Dr. Duffy, please unmute and share your insightful thoughts to the audience gathered here.
Well, I was first in India 40 years ago, And as I'm sure all of you know, once you've been in India, it never gets out of your blood. And now I have not been in India in more than a decade, and so it's a great pleasure to speak to an Indian conference. I can pretend that I'm in India again. I also feel I'm coming home in another sense. I see Scott McNeely and Bill Redu. The focus of my work, my desires throughout my entire career has been individual freedom. People often talk in terms of democracy. I can't see how you can have a free society without it being a democratic society, but it's amply evident that you can have a democratic society that is not a free society. And a lot of this has to do with the distribution of capability, productive power, decision-making, etc. And so my large interest is in decentralization. Now, looking very broadly, look to biology, I'm very encouraged because the basic manufacturing process in biology is protein synthesis and occurs in every individual cell. On the other hand, if I look at the universe as a whole, I'm not so encouraged because the manufacture of heavy elements takes expensive objects like supernovae and colliding neutron stars, and it's very centralized. But looking to human constructs, the same issues apply, if not the same grandiosity. And we had as great a tool maybe as has ever occurred in human history, born approximately 35 years ago with the World Wide Web, the single biggest application running on the internet. And I believe that artificial intelligence, generative artificial intelligence, is the most powerful tool to have been developed since then. Now, I want to quote again from that UN report that was cited a few minutes ago, because it was quoted by the Center for the AI and Digital Policy. It said, the UN warns of growing AI inequality as the market approaches 4.8 trillion, with just 100 companies controlling 40% of R&D investment. The White House has issued federal AI guidance requiring chief AI officers, etc. And it's that first point, 100 companies controlling nearly half of the investment. And I think we are looking at a danger of having a small number of companies, and very frequently these things contract by mergers and goings out of business and so forth. Might be many fewer than that, controlling artificial intelligence, which means, roughly speaking, they will have to control the policy over what artificial intelligence is willing to do for customers. It would be much better if artificial intelligence is widely distributed, is accessible in all of its manifestations to many, many millions of people. And so that's what I think, this discovery that AI can be done using the ubiquitous CPUs rather than the rarer and inherently more expensive GPUs is the best, one of the most exciting things I have seen in quite a number of years. So I salute this work and I hope to see it bloom.
Thank you so much, Dr. Duffy, for sharing your wonderful thoughts with us today. It's a privilege to welcome Dr. William J. Raduchel, one of Silicon Valley's most renowned technologists. He is a celebrated technology strategist and has served as the Chief Technology Officer of America Online and Time Warner and the Chief Strategy Officer at Sun Microsystems. In addition to being a leading technology executive, Dr. Radushel is also a respected educationist and was a professor at Harvard University. Over the years, he has worked with several global organizations and has authored 2 books. One of his recent works, The New Technology State, explores how technology reshapes society and what actions can be taken to address its growing influence. Dr. Radushel will be addressing us virtually today.
Thank you. Good morning. I look at the audience and I am old. And when I was your age, the computer I worked on most was an IBM 1620. It had 10,000 decimal characters of memory, and you critically were dependent on punch cards because you had to run most things through and do intermediate storage and cache onto punch cards. And then we went on to the mainframe age. And I think what we're talking about today is equivalent for AI with the invention of the microprocessor. I mean, we lived in a mainframe age, and that is where AI is today. You know, mainframe doesn't even begin to look at what Stargate is trying to do to go build its next generation model for OpenAI. But it was a world. I actually used to teach a course on the social implications of the world when having it dominated so much by IBM and then later Microsoft. And as I agree with Dr. Duffy, you know, decentralization is the key to freedom. Decentralization is also the key to getting the value out of the technology. I've watched technology now. I started writing software 65 years ago. And so I've watched this over, you know, almost 7 decades. And technology always finds its own level. But it's the ingenuity of people figuring out how to apply it to their day-to-day life problems that is what's going to make it valuable and where it goes. Yes, there are going to be some great things that are done, discovering new drugs perhaps, that AI will enable that we haven't been able to do before. But what's key and what really changed the computer revolution was 2 things. One, it was the invention of the internet. I actually built the first global IP network at Sun before there was the internet. And then the other thing is the distribution of computing. And as I said earlier, I think what's happening here today is the equivalent of the invention of the microprocessor. And it is the microprocessor which in the end enabled Sun Microsystems. Without the microprocessor, we never could have done what we did there. And then as those microprocessors got more powerful, we did more and more and more and more. And AI is going to do the same thing. Am I afraid of it? Yes. I mean, technology, you always have a 2-edged sword. It always does things that are good, but people can also use it to do bad. And it has impacts on our society, one of which reason I wrote a book on that. But you're going to get the most value and assure the greatest value if we can distribute it and put it out there. And that is what microprocessor did. Everything we did today in the smartphones people carry all over the world. I mean, we have services with billions of users all talking to microprocessors. And it's going to be the same thing. And until we get the ability to use AI on CPUs and get it out so we can use the installed base, we're going to be hindered, and we're going to have back to a world of IBM and Amdahl and a handful of other companies in a mainframe world. And I think that's ending today. I think what you're seeing is this ability to broadly distribute the inference and things so that we can have and use AI everywhere in our lives, everywhere in our economies, everywhere in our societies. So I've been thrilled. I've been working with Ziroh Labs now for 3 years, and I think, you know, what they've done here and bring to market is profound, and we're going to see its impact for years ahead. Thank you very much.
Thank you, Dr. Radushal, for joining us virtually and sharing your wonderful thoughts with us today. Next, we invite J. Seduraman, a successful serial entrepreneur in Silicon Valley, brings his vast knowledge, experience, and expertise of wide area and local area networking. He is a specialist in design and development of semiconductors and systems for optical networking. He was the co-founder of CTO and Fiberlane and Apigee. These companies became highly successful and were acquired by leading technology companies in Silicon Valley. His contributions spread over next-generation networking and digital signal processing. Prior to his entrepreneurial efforts, Jay had held management and engineering positions at NEC, Intel, National, and Bell Laboratories. He has joined us virtually to share his thoughts on the AI advantage and compact AI.
Thank you very much for that introduction. Can you hear me all okay? Yes. Okay. I just have a few words to say from the perspective of Silicon Valley as well as Indian startups. For tech startups, a low-cost, accessible AI isn't just an advantage, it's often a necessity. And it's basically necessity for survival and for rapid innovation. Affordable and user-friendly AI platforms and resources will level the playing field, allowing smaller teams to build sophisticated solutions without massive investments. The democratization of AI empowers startups to disrupt markets and create novel products at an unprecedented pace. By embracing accessible AI, startups can drive the next wave of technological innovation and advancements. I'm really looking forward to seeing compact AI impact on this field, on AI, in the next wave of AI startups. I don't have much to say. Thank you very much for giving me the opportunity to say a few words.
Thank you so much, sir. Now, we invite Mr. Ore Adeyemi to join us virtually. He completed his BSS and BS as well as his MBA from the prestigious MIT. Following his MBA, he worked with several renowned companies and spent nearly a decade at HSBC Capital, where he held leadership roles in London and San Francisco. He later established his venture capital fund, Ode Capital, a proud investor in Ziroh Labs as well. We look forward to hearing his valuable insights on the rise of cost-effective AI unlocking exponential opportunities.
Thank you for the kind introduction. I'll make this, I'll go through this real quick. It's really a privilege for me to be part of this ceremony. To talk about the rise of cost-effective AI unlocking exponential opportunities. So, when addressing a distinguished gathering of world-leading AI academics and innovators, it's always a learning time, and I've learned a great deal just being here. The key thing that I'd like to share with you, which I believe someone also mentioned, is that we stand at a pivotal moment. For years, AI's potential has been talked about, but often accompanied by concerns about high cost and complex implementation. But now the landscape is shifting, especially with the introduction of compact AI. We're entering an era where AI will become increasingly cost-effective, and this evolution is unlocking truly exponential opportunities. So let's talk about some relevant issues here. First, efficiency and optimization will be driven across different industries. Cost-effective AI has the ability to revolutionize industries. We know in manufacturing, it can optimize supply chains, and it can enable predictive maintenance, drastically reducing waste and downtime. Healthcare is another example where we have cost-effective AI accelerating things like drug discovery and personalized treatment that will lead to better outcomes at lower cost. In finance, I was at HSBC for well over 16 years. When we talk about detecting fraud and automating customer service and improving efficiency, that's another example where we can see the use of cost-effective AI. Secondly, another point, we're seeing democratization of AI, and some of the speakers have talked about this. The high cost of computing power, cloud services, and proprietary tools are inhibiting the democratization of AI today. Advanced AI development, as we see it, has remained largely with the top and the big tech giants, and this has prevented startups and small enterprises from fully leveraging its potential. This limits innovation and slows the development of diverse application. But we know with compact AI, we believe this can change and will change. Another third point is bottlenecks to wider adoption that we see. AI models, as we all know, and as shared by several speakers today, rely heavily on GPUs. They're powerful, but they're expensive resources, which not only costly, but they're also limited in availability. So this makes scaling AI solutions a significant challenge. When we run these advanced models on CPUs, they will lead to performance bottlenecks, making real-time or large-scale deployment nearly impossible. Techniques like, that we know about, like quantization and distillation, help reduce the computational load. But what usually happens is accuracy often takes a hit, making these solutions far from ideal. This poses a major problem. AI remains out of reach of many researchers, developers, and institutions, and this goes to the digital divide that was talked about earlier on, especially those without access to elite infrastructure. But the increasing cost effectiveness will help address all these problems. And that's where compact AI comes in. We believe that compact AI can help solve these problems. Compact AI for us, and spending time with Rishikesh and his team, is the first infrastructure product in the global market to unlock true value of AI on CPUs. Already we know the platform supports 17 foundational models, with plans to support over 100 later on this year. AI models will be available across thousands of data centers worldwide as a result of developers no longer having to wait for limited GPU resources. With this comparable speed of inference as expensive GPU chips, we believe compact AI's platform makes development for next generation AI applications faster, it will be cheaper, and highly accessible. This will definitely foster a wave of innovation, driving new applications we haven't even imagined yet. So to bring it to a conclusion, breaking open cost-effective AI is not a future possibility. It's our present reality that must happen. And it's a welcome development to see IIT Madras and compact AI making this a reality. We now have a unique opportunity to shape the future, to drive the responsible and widespread adoption of AI that will benefit these industries I mentioned and much more. But not just the industries, but society as a whole. So I encourage all of us, let us embrace this challenge and unlock the exponential opportunities that lie ahead. Thank you so much for letting me share these words with you.
Thank you so much, sir. We're pleased to invite Mr. Ajay Goyal, who previously served as India's country head for Sun Microsystems. Following his tenure at Sun Microsystems, he moved on to a leadership role at Cisco and was subsequently the MD of Symantec. He is on the Ziroh Labs board and has been part of their journey since day zero. We welcome him to share his valuable thoughts on affordable artificial intelligence and compact AI.
Good morning, everyone. Real pleasure for me. First thing, I'm extremely proud to be speaking here at the most distinguished technology institute in the country. Secondly, I'm extremely proud today for these brilliant engineers, including Rishikesh, Indian scientists and engineers who have invented real cutting-edge technologies and are integral part of the research and innovation ecosystem of the technology. Believe me, these boys and girls, young, come from tier 2 and tier 3 cities, have invented something outstanding. I'll share some technology part of it today before we actually deep down into detail of the technology. I'm going to share only few messages to you. I was very privileged and honored to be part of Ziroh Labs team and observe them in the last many years now. And I have seen the kind of work these boys and girls have done. Very deep inventions. I want to share two of them with you. A lot of you are mathematicians as well here. The team at Ziroh Labs invented the fully homomorphic encryption algorithm, a new mathematics that enables encrypted data processing without any decryption required, with a very small bloat size and a very small computing overhead. And the second big invention which has happened from Ziroh Labs team is this new AI computing engine. This is truly a deep tech invention, and I'll share some more insight about it. That's why I'm extremely proud of it. I'm extremely proud that Turing Award winners like Diffie, Professor Diffie, Professor Reduccio talked about it. They acknowledged the kind of inventions it has happened, and largely done by Indian engineers. Compact AI, let me go a little bit more into compact AI. It's a completely brand new computing AI computing engine. It's built grounds up with a complete new mathematical approach of AI and new technology innovations in the computing science. I don't want to take the thunder away from Rishikesh's talk to share a little bit more detail about it, but it's truly a cutting-edge work done to make CPUs perform at the highest level and performing AI functions. The main theme of this, as we heard, democratization of AI, it should be available to everyone. People should be able to use it. People should be able to afford it. And I truly believe that this will make changes in our AI landscape. I am very excited not only by the release, what you're going to see today. I'm very excited about it. It's a great release. But I'm still very, very excited about the future roadmap. I'll give you a little peek inside that. The future roadmaps are currently under validation and testing, and it will be released very, very soon. Pravartak team and IIT Madras is helping us to do these validation processes. We're not going to only do inferencing only. Take my words. We will be doing fine-tuning of all the models which comply to OpenAI frameworks in the future. We will be doing inferencing, we'll be doing fine-tuning, we will be releasing federated learning. We will be also releasing in the roadmap a privacy-preserving AI, because the biggest concern on the earth is the data set which is in a plain text for doing training and inferring. This is core inventions. I'm extremely proud. Why I'm proud? Indian team of engineers have made this possible to do all these things. Lastly, I would like to thank you very much, Professor Kam, Professor Sadgopan, Professor Madhu, and your team here. You know, they guided us. They advised us. They validated our hypothesis. They validated what we have built. They are continuously providing inputs for the future development and future releases of this. And we believe that I personally strongly believe that compact AI can bring a very compelling alternative for the AI users. Thank you very much, my friends.
Thank you so much, sir. Now it's time to see the product in action. I invite Mr. Hrishikesh and Ms. Ignita from Ziroh Labs to take us through a live demo of Compact AI.
There is a deck that I shared before. You want a browser? No, there is a deck. Where it is? I shared with that email. In that email, I was asked to send that email. You sent that email, right? You emailed that. Can I use that mic?
Yeah, you can use that.
Yeah.
Change the screen. Change the slides.
Thank you everyone for coming today. So before we demo the product, we wanted to tell you what's the inspiration for developing the product. So as Ajay Goel has said before, where we spent a lot of time doing cryptography. And then back then in 2021-22, when we were studying the different aspects of the large language models and how to make it private, we realized that there are a lot of scope even there to improve. And the mathematics and the things that we have done in cryptography really helped us to understand the AI models on the underlying complexities and the mathematics of AI model to somewhat more clearly. So one thing that we realized in 2022 is that if the trend of AI development goes like this, it is extremely unsustainable. Only a few set of companies will be able to do AI. And a large part of users and a large part of other companies, they will only be calling APIs released by some other companies. So therefore we thought that we need to develop something and which can run on top of commodity hardwares. Commodity hardwares meaning CPUs. So to drive down the demo and what the work that we have done, let me tell you a very small story, and this is actually very real. One is that suppose a class 7 student studying in CBSE and the medium of instruction is English wants to learn history. So basically he has two different options. One is that he gets a good teacher, and second is that he can go online. Now getting a good teacher, we all know, is extremely difficult proposition. There are many teachers, but getting a good teacher is difficult. Online, there is one more problem. Most of the online courses are one way. That means the professors come in the TV or the computer and they will tell what they want to tell, and then you will take notes and that's it. But learning, as we all know, is continuous and a series of iterative questions and answers over a period of time, the true learning. Now, how do you solve that problem? And for a country like India, the problem is very skewed. So the ratio between teachers and students and the number of students that are there in India are extremely high, or at a very large scale. So therefore, one of the ideas that can be done probably is that we design an AI model. And that AI model teaches only one thing, which is history. And as Professor Kamakoti sir said in his address, that we don't need to learn everything. That small, simple model can only learn the class 7 history, and it can be therefore be deployed on all different kinds of devices, online, offline. And then it can teach the student what he wants to learn. He can learn interactive, non-interactive, ask questions, prepare for exams, so on and so forth. And all of these things can happen. But then this small, simple goal to enable a class 7 student who wishes to learn history in India has a huge technological breakthroughs that needs to be done in order for this thing to happen. And what are those? For example, I carry 2 phones. One is an iPhone 14 and the other one is a phone that is less than 10,000 rupees, a smartphone. And the 10,000, sub 10,000 phone is actually India. A lot of people carry phones. They have very limited power. They have very limited CPU, very limited memory. So now if you design a model and then you want to provide it to all the students that are there in India, therefore it has to run on that CPU, number one. There are no GPUs in this world today that is being there in a phone. I mean GPUs like what NVIDIA has created. There are mix of CPUs, GPUs on phones today, but most of the phones that are out there in India, they are all CPU based phone with very limited memory. Second, as Ore said in his talk, that yeah, there are methods like quantizations, there are methods like distillations. But then this topic of allowing a student to learn class 7 history is a very important one. You cannot make a model which predicts out or outputs something which is wrong, because learning is a serious business. So therefore, your model not only has to be running on a CPU, a low-end CPU, but it also has to run, it has to be full of quality, it has to be accurate. Now meeting both these objectives and then allowing a particular model to run on a phone is actually a very hard job technically. And this is one of the things that Compact AI has solved. So one of the core messages is that you take a model, you can take that model and run it on a device, and it is a CPU device. You do not do quantization, you do not do distillation, and it can run at a pace which will produce enough tokens so that the quality is there, and at the same time no loss of correctness is there. So it is always correct. So this is one aspect of it. The second aspect of it is that even if you develop the product and a startup goes out to the market and then they want to make it a GTM out of it, it is difficult because GPUs are inaccessible or they are very low in number, and then it's not available everywhere. So if you now put the application on top of CPUs, then the startup can go at any pace in any cloud data center or even on-prem and deploy the solution. And the third and the most important thing when it comes to IIT Madras is that AI researchers or computer scientists, when they want to build a model, they also want to design newer and newer architectures. So if newer and newer architectures needs to be designed, then it also has to be trained. Now to train, you need GPUs and you need a lot of data. So as Professor Kamakoti said, yeah, the lot of data is there, but you still need GPUs. So Compact AI solves the problem, and as our esteemed board director Ajay Goel has said, we are now focusing on the inference. Very soon we will provide a framework on Compact AI to do fine-tuning first and then the full training, and eventually we will also provide privacy on top of the Compact AI platform. So now I request Ignita to do a small demo that will demonstrate the product. So here, yeah.
It's a live environment, CPUs are here. Everything happens right in the room. Yes.
So we all love maths, we all love AI, and math being the basic building block to design and build AI model architecture. So we have loaded a math model on Intel Xeon Silver 24 core CPU, which is running over here. and I request Professor Kamakoti to run the first inference. The display is over here.
You can see.
So this is a Quen model. It is developed by Alibaba, and it is a math model. It is trained to understand mathematics and solve equation, and the size of the model is 1.5 billion parameters.
And it is running on a CPU. It's a commodity CPU, and these are the CPUs. Yeah, and as you have seen, it is fast enough. So for these models, which is 1.5 billion and up to 10 billion, up to 50 billion parameter models, you don't really need a GPU anymore. You just take the model, put it in the compact AI framework, and then it works. And as we discussed, this model is not quantized, by the way. It is also not a distill model. It's a full scale model with full quality. Right? Yeah.
What do we love next? Programming, right? So we have a programming model that is loaded on Intel Xeon Gold processor. It's a 48 core processor. So this is again a Quen model. It's a Quen coder instruct model, and the size of the model is 7 billion parameters. 7 billion.
7 billion.
So it is trained to understand and write program. So you can generate the code, you can debug, you can ask it to review the code. Yes, so let's say a programmer wants to implement an algorithm using Java. So this particular model not only generates code, it can also explain you how the code works. It can explain you how to build the project, load the project, and deploy it on the server. So we have another model which is again on text, and I think most of us might have used it. It's text summarization. So basically you give a large text or you give a document as an input, and you expect the model to summarize it and make it a short story for you so that you can read it quickly. Right? So here we are using a model designed by Microsoft, which is 3.5 mini instruct, and the size of the model is 3.8 billion parameters, and this particular model is trained on a larger context so that it can understand the larger context. So you can see the input is fairly large over here, so it understands the context and summarizes in the way you instruct. So you can say, can you give me the summary in 20 words? Can you show me the summary, say, in 2 sentences? It can also do more than just summarization. It can do things that you can actually do with the text. You can ask questions. You can upload a document and you can do Q&A. You can do extraction of the data, etc. Right? So this is the summarizer, and it is running again over here on Intel Xeon processor. It's a silver processor and 24-core machine. We also have a model that was fine-tuned for a particular use case. So may I request Professor Madhu to come and explain the BERT model.
Thank you. So basically this is an application for legal experts. Again, it has been built from, it's more of a foundational model based on the BERT architecture, only about 130 million parameters. And when we talk about legal context, the challenge is opinions. And this model tries to extract the key components. And the entire model has been built ground up from IIT Madras and IITM Pravartak. So the focus has been on high quality data. The focus has been on high quality data. Domain experts, we had the lawyers, and this model understands only legal jargon and nothing else. Right? Thank you. So we are just giving a legal document. How many pages is it? About 600 pages, and it basically tries to find all the entities and take it forward. So here what is happening is we call it as named entity recognition. It has been customized, and the advantage about this is from using this data, you can write business logic, whether it is for a advocate, whether it is for an end user, or whether it is for a judge. So no, this particular model can be adapted for any domain or no end user application as per the requirement. Thank you.
And finally, we have one more app which we all are familiar with, AI chat. So here we have loaded Llama 2 7B, and we have loaded it on GCP, again Intel Xeon processor, 24 cores. Yeah, so the prompt for AI chat is, I want to go to Chennai for 3 days and help me plan it, and it generates a response for us. So here you can see the machine configurations architecture as well. So it's loaded on 48 core machine which has 96 vCPUs, and you can also see the cache size, where the largest cache, which is L3, is 260 MB, and this model is of size 7 billion parameters. Thank you.
So two things over here. So these are 4 different models, and what we did along with IIT Madras and IITM Pravartak is the BERT model. Apart from that, we have built now more than 20 models. It includes even the DeepSeek series, the Qwen series, the 2.5 series from Alibaba, the Microsoft Phi series, as well as Facebook or /Meta's Llama series as well. So these models we have already ported. There are about 100 more that are coming in the next couple of months. And all these models put together, about 160-70 of them, all within that 50 to 70 billion range per parameters. All of these will be able to do like this on top of CPUs with no requirement for GPUs. One other point that I wanted to bring out, is that when DeepSeek was launched in the last week of January, it said two interesting things. One, it said that DeepSeek has built a model which is equivalent to OpenAI. Okay. The second part with the conjunction N is that, and it is built on top of GPUs H800, limited in number, and the inferencing that was happening on DeepSeek during those days and even today are on GPUs. With compact AI, we can very confidently say, with a cluster of CPUs and a very good network, very good meaning 10 Gbps network, you can do DeepSeek 670 billion parameter and produce from 17 to 40 tokens depending on the network. And to do that, you don't really need a GPU anymore. All can be done on top of CPUs. So therefore, we are confident that if we can do 670 billion, then as Kamarsa said, we'll of course do 500 million, 200 million, 1 billion, 2 billion, we will do very confidently. And these are the models that India requires now, or rather the globe requires. So therefore, we are confident that we can take it forward together and then create a beautiful product out of India to the global. Sir.
That comes to the end of the demos. Okay, don't you think that the demo team needs a standing ovation from all of you? Please join me. Thank you.
I now welcome Dr. Madhusudanan from IITM Pravartak to present the powerful capabilities of IITM's foundational AI model.
Thank you. Good morning all. To members on the dais, distinguished dignitaries who have joined virtually, fellow members, startups and dear students. It's a pleasure to be here today to share a unique experience that sits in the intersection of academia and innovation, academia and innovation. As an academician with vast industry experience, I have always believed that the true impact of research lies in its application, and that is where the principles of IITM Pravartak stands. This belief was reaffirmed during my recent collaboration with the dynamic startup Ziroh Labs, working on a groundbreaking AI-based inferencing, which you have already seen today. When I started collaborating with them, I've been collaborating with them for quite some time with the Ziroh team. What caught my attention was their algorithmic approach and not just some technical ambition. It was the novelty of their approach, which is unique. Unlike conventional inferencing pipelines, the solution aimed to bridge gap between the hardware and software. And my journey with Ziroh has been twofold. Firstly, I worked with the team to dissect and understand their inferencing architecture. Second, I led the validation of their systems through rigorous academic and industry frameworks, both qualitative and quantitative. And that is where the conviction started happening. Seeing the performance benching, it was as good or as bad of the current industry standards. So thank you very much. It was a calm, I think.
ஸோ ஐஐடி மெட்ராஸில் என்ன ப்ரெஸ் மீட் பண்ணாலும் நிச்சயமாக தமிழில் பேசலைன்னா அது நிறைவாகாது. அதனால் இப்போ இப்போ நான் தமிழில் பேசுகிறேன். Diffie and all, I am going to narrate the same story in Tamil, so please do listen to our language. It's our mother tongue in Tamil Nadu. இன்னைக்கு செயற்கை நுண்ணறிவுங்கிறது ஒரு பெரிய ஒரு விஸ்வரூபத்தை எடுத்திருக்கு. இதில் குறிப்பாக நமக்கு நிறையா ஹார்ட்வேர் தேவைப்படுறது. அந்த ஹார்ட்வேரை இயக்கிறதுக்கு நிறையா பவர் எனர்ஜி தேவைப்படுறது. இது ரெண்டும் வந்து ஒரு சாமானிய ஒரு மிடில் ஒரு ஸ்டார்ட் அப், மைக்ரோ ஸ்டார்ட் அப், மீடியம் ஸ்டார்ட் அப்ஸுக்கு, மீடியம் இண்டஸ்ட்ரிக்கு, அவங்களுக்கு ஏஐ அவங்க ப்ராசஸில் எடுத்துன்னு போகணுன்னா இது ரெண்டும் ஒரு பெரிய லிமிட்டேஷன். ஒன்று ஹார்ட்வேர், இன்னொன்று எலக்ட்ரிசிட்டி கன்சம்ஷன். இன்றைக்கி ஹார்ட்வேர் வந்து இந்தியாவுக்கு கிடைக்காத ஒரு சூழ்நிலையும் வர ஒரு நிலைமை இருக்குது. ஏன்னா உலகம் முழுக்க நிறைய அந்த ஹார்ட்வேருக்கு டிமாண்டாக இருக்குது. அந்த ஹார்ட்வேர் பேர் தான் ஜிபியு. இந்த கிராஃபிக்ஸ் ப்ராசஸிங் யூனிட்டை பற்றி நான் இங்கிலீஷில் எக்ஸ்பிளைன் பண்ணுறேன், அதே உங்களுக்கு சொல்கிறேன். கிராஃபிக்ஸ் ப்ராசஸிங் யூனிட்டுங்கிறது சிங்கிள் இன்ஸ்ட்ரக்ஷன் மல்டிபிள் டேட்டாங்கிற பிரின்சிபலில் அது வேலை செய்யுது. அதாவது ஒரு 100 நம்பரை நம்ம மல்டிப்ளை பண்ணணும்னா ஒரே ஆள் மல்டிப்ளை பண்ணார்னா 99 மல்டிப்ளிகேஷன்ஸ் பண்ணால் ஆன்சர் வரும். இதுவே 10 பேர் இருந்தால் ஆளுக்கு 10 நம்பரை மல்டிப்ளை பண்ணி அதோட ரிசல்ட்டை அப்படியே இன்னொரு தடவை மல்டிப்ளை பண்ணி கொண்டு போகலாம். அதனால் இன்னும் கொஞ்சம் ஃபாஸ்ட்டாக முடியும். ஒத்தரே வச்சு மல்டிப்ளை பண்ணுறது சீக்வென்ஷியல் கம்ப்யூட்டிங்னு சொல்லுவோம். பல பேர் வச்சு மல்டிப்ளை பண்ணுறது பேரலல் கம்ப்யூட்டிங்னு சொல்லுவோம். இந்த பேரலல் கம்ப்யூட்டிங்கில் இந்த மல்டிப்ளிகேஷன் உதாரணத்தில் நமக்கு என்ன இன்னும் இம்பார்ட்டண்ட்டாக அதை பார்க்கணுன்னா, எல்லாரும் மல்டிப்ளை தான் பண்ணுறான், ஆனால் டிஃப்ரெண்ட் செட் ஆஃப் டேட்டாவில் பண்ணுறான். அதனால் சிங்கிள் இன்ஸ்ட்ரக்ஷன் மல்டிபிள் டேட்டா. இதுதான் அந்த காலத்தில் கிராஃபிக்ஸ் ப்ராசஸர்ஸ் அவங்க கண்டுபிடிச்சாங்க. சிலிக்கான் கிராஃபிக்ஸ் 1995 வந்தது. அது என்ன மூவி? அனிமேஷன் மூவி. 1995 அனிமேஷன் மூவி. 1995 ஒரு டினோசார் போட்டு ஒரு ஜுராசிக் பார்க், சாரி வயசாகுது, ஜுராசிக் பார்க்னு ஒரு மூவி. அதை 1996 சிலிக்கான் கிராஃபிக்ஸ் பண்ணாங்க. அந்த டைம்லலாம் உங்களுக்கு இந்த கிராஃபிக்ஸில் இந்த சிபியூவே கிராஃபிக்ஸ் பண்ண முடியல. இந்த சிபியூ வந்து ஆப்ரேட்டிங் சிஸ்டம்லாம் முடித்து ரொம்ப ஸ்லோ ஸ்பீடு. அதனால் இந்த கிராஃபிக்ஸ்க்காக தனியாக ஒரு ப்ராசஸர் தனியாக இருக்கும். இந்த சிபியூ வந்து அந்த கிராஃபிக்ஸ் ப்ராசஸருக்கு இன்ஸ்ட்ரக்ஷன் கொடுக்கும், அந்த கிராஃபிக்ஸ் ப்ராசஸர் வேலை செய்யும். நீங்கள் இந்த கிராஃபிக்ஸை பார்த்தீங்கன்னா அதில் எல்லாமே இந்த சிங்கிள் இன்ஸ்ட்ரக்ஷன் மல்டிபிள் டேட்டா, நிறைய சிங்கிள் இன்ஸ்ட்ரக்ஷன் மல்டிபிள் டேட்டா, அதில் அது மாதிரியான கம்ப்யூட்டேஷன் நடந்தது. அதாவது 2 இடத்துல சேர்ந்து லைன் போடலாம் இல்லையா? அது மாதிரி இப்போ 10 நம்பர் 10 பேர் ஆளுக்கு 10 நம்பரை ஒரே சமயத்தில் மல்டிப்ளை பண்ணுற மாதிரி ஒரு கிராஃபிக்ஸை 10ஆக பிரித்து 10 யூனிட்ஸ் அதை டிஸ்பிளே பண்ணலாம். எல்லாம் சேர்ந்து ஒரு பெரிய படமாகும். இது மாதிரி தான் அந்த காலத்தில் கிராஃபிக்ஸ் ப்ராசஸிங் யூனிட் வந்தது. அதுக்கப்புறம் இப்போ ஏஐயில் செயற்கை நுண்ணறிவில் நீங்கள் இப்போ இந்த சாட் ஜிபிடி, டீப் சீக் இது மாதிரி பல லாங்குவேஜ் மாடல்ஸை நீங்கள் யூஸ் பண்ணுறீங்க. அதில் 2 விதம் இருக்குது. ரெண்டு ஸ்டெப் இருக்குது. முதல் ஸ்டெப் வந்து அதுக்கு சொல்லிக் கொடுக்கறது, பாடம் சொல்லிக் கொடுக்கறது. இது வந்து ட்ரைனிங்னு சொல்கிறோம். அதுக்கு நல்லதையும் சொல்லிக் கொடுக்கணும், கெட்டதையும் சொல்லிக் கொடுக்கணும். அது நல்லது கெட்டது அது பார்த்து அது நமக்கு அழகாக ஆன்சர் கொடுக்கும். இது வந்து ட்ரைனிங். அடுத்தது அதை நம்ம இப்போ கேள்வி கேட்குறோம். இப்போ நீங்கள் எல்லாம் இப்போ சாட் ஜிபிடியில் லாக் பண்ணி கேள்வி கேட்குறீங்க, ஆன்சர் இந்த அசைன்மெண்ட் ப்ராப்ளத்துக்கு என்ன ஆன்சர்னு கேட்குறீங்க, சம்மரைஸ் பண்ணுன்னு சொல்கிறீங்க. இதெல்லாம் வந்து இன்ஃபரன்சிங்னு பேர். ஸோ 2 விதம். ஒரு ஏஐ மாடலை டெவலப் பண்ணுறது, அது பாவம் அது குழந்த, அதுக்கு முதல்ல எல்லாம் சொல்லி கொடுத்து அதை நல்ல மேதாவியாக்கி அதுலேருந்து அதுக்கு நம்ம வந்து அப்புறம் கேள்வி கேட்டால் அது பதில் சொல்லணும். இதுதான் 2 ஸ்டெப். இப்போ இயற்கை நமக்கு என்ன சொல்லி கொடுத்துருக்குன்னா 64 கலை இருக்குன்னு சொல்லியிருக்கு. அந்த 64 கலையும் தெரிஞ்ச ஒரு ஆள் இருக்காரா? இல்லை, இருக்க முடியாது. ஏதோ ஒரு 2-3 கலையில் நமக்கு ஒரு நல்ல ஒரு வித்வத் வரலாம். இப்போ இந்த பல லார்ஜ் லாங்குவேஜ் மாடல்ஸ் அவங்க என்ன சொல்கிறாங்க, 18,000 கோடி பேராமீட்டர் இந்த பராமீட்டருங்கிறது எத்தனை அளவு நம்ம அறிவு சேர்க்குறோமோ அதுதான் அந்த பராமீட்டர்னு சொல்கிறோம். இந்த லார்ஜ் லாங்குவேஜ் மாடல்ஸ்லாம் என்ன சொல்கிறான், 18,000 கோடி பராமீட்டரை நான் பார்க்குறேன், 20,000 கோடி பராமீட்டரை பார்க்குறேன்னு சொல்கிறான். உலகத்தில் இந்த யூனிவர்ஸில் அண்ட சராச்சரத்தில் இருக்கிற அத்தனை ஞானத்தையும் நான் வச்சுப்பேன், நீ என்ன கேள்வி கேட்டாலும் சொல்வேன்னு. இது இயற்கைக்கே இது சரியாக வராது. அதில் என்ன ஆகுதுன்னா, இப்போ நிறைய டேட்டா ஜெனரேட் ஆகிட்டு இருக்கு. ஒரு நாளைக்கு நீங்கள் பார்த்தீங்கன்னா நீங்களே எத்தனை டாக்குமெண்ட், எத்தனை வாட்ஸ்அப் அனுப்புகிறேன், எத்தனை எல்லாமே டிஜிட்டல் டேட்டா. இத்தனை டேட்டாவையும் அது கலெக்ட் பண்ணி அது பண்ணணும்னா அது உலகத்தில் இருக்கிற அத்தனை எனர்ஜியும் அதுவே குடிக்கும். அதனால் அது எனர்ஜி எஃபிஷியண்ட்டாக இருக்க போகிறதில்ல, அதுக்குள்ளே ஹார்ட்வேர் அவ்வளோலாம் கிடைக்கிறது ரொம்ப ரொம்ப கஷ்டம். அதனால என்ன ஆகுதுன்னா, நமக்கு நம்ம டிஜிட்டல் ரிவல்யூஷன் வரத்தே டிஜிட்டல் டிவைடுன்னு ஆச்சு. அதாவது சில பேருக்கு இன்டர்நெட், சில பேருக்கு டிஜிட்டல் டெக்னாலஜி இருக்குது, சில பேருக்கு இல்லை அப்படிங்கிற ஒரு ஸ்டேட் வந்தா மாதிரி இந்த ஏஐ டிவைட் அப்படிங்கிறது வரும். இது நம்ம ஒண்டி சொல்லலை, இன்னைக்கு யூஎன்ல ஒரு ரிப்போர்ட் போட்டிருக்காங்க, ஏப்ரல் மாதம்தான் அது ரிலீஸ் ஆகிருக்கு. அதில் அவங்களே சொல்கிறாங்க, ஒரு ப்ரிவிலேஜ்டு ஃபியூ, ரொம்ப பைசா நிறையா இருக்குது, நிறைய எனர்ஜி இருக்குது, நிறையா செலவழிக்கலாம் அப்படிங்கிறவங்களுக்கு கொண்டு ஏஐ இருந்ததுன்னா, இந்த சாதாரண ஒரு மைக்ரோ இண்டஸ்ட்ரியோ மிடில் இண்டஸ்ட்ரியோ அவங்களுக்கு ஏஐக்கு எங்கே போவாங்க அப்படிங்கிற ஒரு கேள்வி நிற்கிறது. அதனால ஒரு ஏஐ டிவைடு வரும் அப்படிங்கிற ஒரு நிச்சயமாக நம்ம இதுக்கு ஏதாவது ஒரு புதுமையான ஒரு சொல்யூஷன் கண்டுபிடிக்கலைன்னா சில பேருக்கு ஒண்டி தான் ஏஐ, சில பேருக்கு ஏஐ இல்லைங்கிற ஒரு காலம் வரும். அது நல்லது இல்லை, அது ஏஐ ரெவல்யூஷனுக்கு நல்லதில்லை. இதற்காக தான் இப்போ அந்த நோக்கத்தோடு நம்ம பார்த்தோன்னா, எங்களுக்கு அனைவருக்கும் ஐஐடி மெட்ராஸ் அப்படிங்கிற மாதிரி அனைவருக்கும் ஏஐ அப்படிங்கிற இதில் எங்களுக்கும் அது ரொம்ப இன்ட்ரெஸ்டிங்காக இருந்தது. ஜீரோ லேப்ஸ் வந்தாங்க, ப்ரொஃபஸர் சடகோபன் எங்களுக்கெல்லாம் ரொம்ப பிதாமகர், எங்களுக்கு கிளாஸ் எடுத்திருக்கார். என் பொண்ணு அதான், என்னோட பேரம் பேத்தி எல்லாருமே அவர் புக்கெல்லாம் படிப்பாங்க. அந்த அளவு இன்னைக்கு டிஜிட்டல் ரெவல்யூஷன் ஆரம்பித்த காலத்தில் அவர் சடகோபன் அது மாதிரி கிரேட் ப்ரொஃபஸர்ஸ் அவங்க இருந்திருக்காங்க. அவங்களோட கைடன்ஸில் இன்னைக்கு இந்த ஜீரோ லேப் இந்த ப்ராடக்டை அனௌன்ஸ் பண்ணுறாங்க. இது என்னென்னா, நீங்கள் ட்ரைனிங் ஜிபியூவில் பண்ணுங்கள், நோ ப்ராப்ளம். அதுக்கப்புறம் உள்ள இன்ஃபரன்சிங், அதாவது கேள்வி கேட்டு பதில் சொல்கிறது, இதெல்லாம் நீங்கள் சிபியூவில் பண்ணலாம் அப்படிங்கிறது இன்றைக்கி டெமோ. இப்போ இங்கே 4 சர்வர் வச்சுருக்கோம். இதெல்லாம் 1.5 லட்சத்துலேருந்து 12 லட்சத்துக்குள்ளே இருக்கிற சர்வர். இதில் அவங்க இன்றைக்கி 4 டெமோ காமிச்சிருக்காங்க. மேத் ப்ராப்ளம் சால்வ் பண்ணுறது, ஒரு காம்ப்ளெக்ஸ் மேக்ஸ், அது சிம்பிள் மேக்ஸ் இல்லை. அதே மாதிரி ஒரு டெக்ஸ்ட் சம்மரைசேஷன், ஒரு லீகல் டாக்குமெண்டேஷன் எல்லாம் சொல்லியிருக்காங்க. ஸோ ஒரு அனைவருக்கும் செயற்கை நுண்ணறிவை கொண்டு போய் சேர்க்கறதுக்கு, குறிப்பாக மீடியம் அண்ட் மைக்ரோ இண்டஸ்ட்ரீஸ் ப்ளஸ் ஈவன் லார்ஜ் ஸ்கேல் இண்டஸ்ட்ரீஸுக்கு கோடியாக செலவழித்து அதை வாங்கி அப்புறம் அதாவது ஒரு சின்ன வயசு யானைக்குட்டியை வாங்கினா 6 மாதம் கழிச்சு அதுக்கு 2 ஏக்கர் வேணும் தீனி போட. அது மாதிரி அத்தனை எனர்ஜி நம்ம வச்சு இதெல்லாம் பண்ணுறது ரொம்ப ஒரு சாதாரணப்பட்ட இண்டஸ்ட்ரிக்கு ரொம்ப கஷ்டம். அதுக்கு இது ஒரு பெரிய சொல்யூஷனாக இருக்கும். இந்த சொல்யூஷன் ஜஸ்ட் இந்தியா கொண்டு இல்லை, பல நாடுகளில் பல இண்டஸ்ட்ரீஸ் இதை யூஸ் பண்ணுறதுக்கு நிச்சயமாக இதோட ஒரு பிரைட் ஃப்யூச்சர் இருக்குது. இதை தான் இன்றைக்கி நாங்கள் இன்ட்ரடியூஸ் பண்ணுறோம். அதாவது நெசசிட்டி இஸ் த மதர் ஆஃப் இன்வென்ஷன். நமக்கு ஒன்று கிடைக்கலைன்னா அடுத்த லெவலுக்கு நம்ம போய் அதை கிடைக்க பண்ணணும். நமக்கு இது கோவிட் சொல்லி கொடுத்த பெரிய பாடம். நமக்கு வேக்சின் வேணுங்கிற போது நெசசிட்டி மதர் ஆஃப் இன்வென்ஷன். 2 வேக்சின் பண்ணோம், 275 கோடி இன்ஜெக்ட் பண்ணியிருக்கோம். அது பண்ண அந்த ஆப் பண்ணவர் எங்களோட ப்ரௌட் அலுமினஸ். எல்லாத்துலேயும் ஐஐடி மெட்ராஸுக்கு கணபதி சார் கொஞ்சம் எழுந்துக்கோங்க. கோவின் ஆப் அவர் தான் பண்ணினார், எங்களோட அலுமினஸ், பெருமையாக சொல்லிக்கிறேன். அதே மாதிரி அது நெசசிட்டி இஸ் த மதர் ஆஃப் இன்வென்ஷன். 2 இது பண்ணோம். அந்த 275 கோடி இன்ஜெக்ட் பண்ணியிருக்கோம். மற்ற தேசத்துக்கு ஃப்ரீயாக நிறைய டொனேட்டும் பண்ணியிருக்கோம். இதுதான் பாரத தேசம், இதுதான் நம்ம தேசம். அதே மாதிரி இன்றைக்கி நம்ம பண்ண சொல்யூஷன் நிச்சயமாக உலக லெவலில் இது ரொம்ப யூஸ்ஃபுல்லாக இருக்கும். இந்த ஏஐ எல்லாருக்கும் போய் சேர்கிறதுக்கு, எல்லாரும் அதை யூஸ் பண்ணுறதுக்கு, அதாவது ஒரு இண்டஸ்ட்ரிக்கு ஏஐ இல்லை, ஒரு இண்டஸ்ட்ரிக்கு இருக்குன்னா அவன் காம்படிஷனில் லூஸ் ஆகி அந்த இண்டஸ்ட்ரி கீழே போகிற ஒரு நிலைமை வருது. அது மாதிரி ஒரு நிலைமை வராமல் இருக்கிறதுக்கு இது ஒரு பெரிய டெமோக்ரட்டைசேஷன் ஆப்பர்ச்சுனிட்டியாக நான் இதை கருதுகிறேன். இன்றைக்கி அனைவருக்கும் IITM மாதிரி அனைவருக்கும் ஏஐ இந்த ஏப்ரல் 8ஆம் தேதி இதை இன்ட்ரடியூஸ் பண்ணதில் ரொம்ப 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 பெருமைப்படுறேன். எல்லாருக்கும் வந்ததுக்கு ரொம்ப நன்றி. வணக்கம்.
Audio.
Primarily static, however, we added Java applets and hello everybody. A long time ago, when we launched Sun and Java, there was a new level of accessibility that came forth to the market. HTML was primarily static, however, we added Java applets and applications went onto the internet. The applet changed the way the internet operated. Many programmers across the globe embraced Java, and it was easier to write code than ever before. It was genuinely object-oriented. And most importantly, it ran everywhere, write once, run anywhere. There was no need to worry about processor architectures, memory architectures, and so on. And as you can see, Java-enabled accessibility across the globe is the result in what we see today, the World Wide Web that is animated and scalable and safe. So we're at that stage now in AI, which has just started. Some architectures have emerged and new hardware to execute them is being designed, lots of innovation. Compact's goal of running efficient and accurate AI on a vast majority of CPUs is not just a technical feat, but a potential catalyst for democratizing AI development. Like Java, it can enable millions of developers to develop test models and use them in production environments, empowering them to contribute to this really cool AI revolution. I want to express my heartfelt gratitude to the entire Ziroh Labs team for the incredible efforts leading up to this launch. Let the revolution begin. Thank you all.
You know, the Scott McNeely mentioned a very important thing, like the way that Java got invented, JVM came into picture. Actually, one of the core invention in today's compact AI is a new VM for AI. It's a Kai VM. So it's a very new way of doing things. As you go and start using it, you will realize it. It's a very, very big inventions in that space, as well as a new mathematics underneath of it.
Java changed the software development. Kai AI will change AI development.
Thank you so much, sirs.
Any questions? Yeah, we'll come to you.
So I have an important question. So now we are in AA. So in the future it will be more economic growth. But what will be the employment opportunities with AA? What is the growth of employment opportunity with AA? Because we are using only automation, not using any pen. Even in compact AI also, the max and all, in school also, we use our brain for factorization or differential calculus or integration. But through AI, we can give the prompt and it will give answer. So what is the useful? What is the economic growth of employment opportunities in future of AI, then what is useful to the students of compact AI?
Okay, so why compact AI? I'll tell you, it's because of energy and other requirements, cost, energy, affordable. I'll answer your question. Yeah, so compact AI. What is the future of AI? இது வந்து நம்ம நிறையவே டிஸ்கஸ் பண்ணியிருக்கோம். We have been discussing this in very great depth in many forums. Most importantly, AI is not going to kill the jobs. There will be a human in loop for everything. Whatever we are demonstrating here also are basically something that can augment your school education. Your teacher teaches something, your AI can help you understand it better, help you clear your doubts. So this is where AI is going to play a role. It cannot replace a teacher. The teacher, the human touch will still always be there. But the teacher can also use AI to see how effectively they can improve the teaching. So if you look at this year's budget, the Honorable Finance Minister has announced AI COE for education. Last year, she announced AI COE for agriculture, sustainable cities and health. This time they are using for education. But every step that we take, there is going to be an upskilling and reskilling. That's what the UN report also says. That we need to go to the next level. We are going with a much faster world. Today, in those days when you want to write a check and transfer money to somebody, it takes 7 days, 6 days. Today we do it in 6 milliseconds, right? So the world is moving fast. There is a more productivity that is needed. And for that, AI will be a very good companion. But people must know how to use AI and how to effectively translate it into action. AI is not going to do the manufacturing for you, but AI will tell you how to do the manufacturing. People should understand that and translate. So there will be a lot of human in the loop. ChatGPT is now 1.5 years old. What job it has removed? No. We need people who will be upskilling themselves and reskilling themselves. So AI will give you a much interesting job profiles. And I'm sure it is going to happen. We have seen such revolutions in the past. We have seen when the banks actually were getting automated. There were a lot of concern that will be losing. But today, when you look at any bank, from the date of non-automation to today, see the amount of employees who have joined. It will be 10x or 20x. So this is always going to happen. And the type of employment that they are doing today is becoming more and more sophisticated and more technology oriented. Thank you. Next question. Yeah. Sure. Yeah, yes. But yeah, whoever asks first. Just pass it by row.
Yeah, so I see that you have said that you have a performance metric of about 3x performance improvements. What power envelope are you doing all of this on? Like, I mean, do you have published performance metrics versus, let's say, DeepSeek R1 or something that you have somewhere?
You are talking about with respect to power consumption or with respect to only the performance?
Both. I mean, performance per watt. Performance per dollar.
Performance per dollar, what we really do is that you take that model, okay, and then you run it on a CPU, and then we calculate based on the standard benchmarks that are available how the model is performing in two different aspects. The first thing that we need to do is we check the qualitative performances. So that while doing quantitative performance very well, we do not lose the quality as well. So we run the same set of benchmarks, for example, that Facebook or Meta has produced. So if you go to the Llama series of papers, let's take the Llama 7B. So they published that, okay, Facebook has done 6-7 different benchmarks, and then these are the results that we have got. So the first thing that we do is that we do that part. Okay. Once we are clear that, okay, that is there, then we go and do the quantitative benchmark. So in the quantitative benchmark, again, there are some numbers, matrices that matrices that are there, metrics. First time to token, and all these things are there. So we start performing them. And then we first look for benchmarks that has been reported by others, say in Stack Overflow, Reddit and all those guys. So if it is there, it's good. But then the next step, we actually procure GPUs, meaning that we take for hire GPUs, and then we run the same model, right? And then we compare an apple-to-apple comparison. Now with respect to power, it's straightforward, meaning that a GPU with a certain T-flop capacity requires so much of power. Similarly, the CPU with certain capacity, G-flop or T-flop of computational capacity requires so much of power. The notion of power and the carbon footprint therefore comes in when you want to jack up the performance or you want to build a distributed system, and then you do the performance on, sorry, not on the performance, sorry, on the carbon footprint. Yeah. Mm. Mm. Yeah, so the first thing there is to determine that, okay, how many tokens you need.
Let's assume that.
So let's assume that X. Okay, X is.
Benchmark, you can take it as 50%. There are 50% savings in terms of.
Yeah.
A benchmark, a rough benchmark, as a rough benchmark. Because we are looking at qualitative, quantitative. Of course, there are a lot of published results which are available in the public domain, multiple research papers. So when we take up a model, or that's how I validated it, when we take up a model, we also take the quantitative results, qualitative results, and see whether the results are almost the same, as good or as bad as what your published benchmark is. So that is the first criteria. The second criteria is, honestly speaking, when it comes to power, it's a slightly much more complicated task with respect to the number of tokens generated and things like that. As a benchmark, you can be pretty sure that the power savings is about 50%. Yeah, can you please, somebody pass the mic there? No, yours.
We are a startup and then we work on breast cancer therapeutics. What's the business model for your compact AI? There should be some business model.
Right now, the business model is to work with you.
Oh, great, thank you. We are a startup and then we work on.
We are also a startup, so we want to work with you. We want to work together and then see how we can help you.
That will be fantastic.
So that you can do the inferencing and for the time being on top of CPUs, get the quality result that you desired at the first place, and then deploy it in your production application.
Perfect, because we work on survival analytics of our breast cancer patients. We don't call patients nowadays.
Yeah, that's a very beautiful
survivors.
use case, and we will be eager to work with you in this regard.
Oh, really great. Thanks for that. Really appreciate that. Thank you.
Good, this democratization comes first to Saraswati, then Lakshmi. Okay, sir. Next. Yeah. He has been asking from first.
So this is pretty cool. One thing I want to ask is, do you have your own runtime that you run on it? Have you developed your own runtime to run these models?
Yes.
That's question one. The question two is, do you have a version of containerization or Dockerize where I can scale in so that
Yeah, I mean, see, containerization like uses of Kubernetes and then uses of Docker, or even creating an Ubuntu image out of it, is more or less a boilerplate today. Okay. Meaning that there are a lot of people, for example, in Chennai, who can do all these things. So because we are also a startup, and as I said, and we have to focus on things. So right now what we are focusing on is on the runtime. Now that runtime, of course, you can put it in a Kubernetes pod or as a Docker image, and then you can scale out and scale it. You can do that.
Okay.
Yeah. In our installations in the cloud that we test and do run different benchmarks, we use these things, Kubernetes and pod, but we do not want to release them.
Understood.
Yeah. Our main focus is to release the runtime.
So I run a startup which focuses on deploying the models.
Then we are great partners.
Yeah.
Yeah.
Thank you. So how it differs from the Hugging Face, for example, it's a serverless inference versus the unlimited inference as you stated with the self-hosted on own server. So in terms of cost, how much we can save? For example, let's take Hugging Face open source model. Whatever.
Yeah, as you say, you will save at least 50%. It's a big money when you do over a period of time.
Thank you.
Thank you. We are running out of time. Thank you.
We'll take it offline.
Thank you so much. As we conclude the formal part of the event, I request everyone to stand for the national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाता जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you all for participating in this enriching morning session. Please join us for lunch and network with fellow innovators. For participants, startups, and industry, the lunch will be provided in the opposite OAT. For media and guests, the lunch will be provided in ICSR and Exshore.